The basic strategy of solving a radical equation where the x is inside the square root is to get the square root by itself. So right now, is the square root by itself on one side of the equation? No. Notice in this one we have more than one square root. In fact, we got more than one square root and more than one number. But can you see that these are like radicals and these are like terms? Anytime in an equation you have like terms, you could put them together if they were on the same side of the equation. So for example, if I move the 1 over to the other side by subtracting 1, that would put them on the same side, and I could combine those like terms, leaving me with 2 on the left-hand side. Similarly, if I subtract 4 root x from this side and 4 root x from this side, that will get me to just have a root x by itself on the right-hand side. And now I have isolated the square root. I've got the square root by itself. So now the strategy to get rid of a square root once it's isolated is to square both sides. Square this side, square this side, and we get x equals 2. How do we verify? We take the original question's left side, the original question's right side, plug in the number for x. Oops. Nobody was going to say anything? 2 squared, and I wrote 2 again. So the other nice thing about verifying is sometimes you realize when you're about to verify, something must have went catastrophically wrong. Because I started writing the numbers in to verify, and I'm like, this is not going to work out. So I checked my answers, and sure enough, I'd forgot to square the 2. On the right-hand side originally, it looked like this. The square root of 4 is 2. So if I simplify the left-hand side, I get 11. The square root of 4 is 2. So if I simplify the right-hand side, I get 11. And since the left side equals the right side, we have verified it. Sometimes you'll even see places where they say you have to write in the end that the left side equaled the right side to show that you understood those numbers were the same. And then sometimes we'll see someone put a check mark by their original answer. Okay. So questions for this one, and we're going to keep going with our examples right now, are 7 and 9. We're going to underline this word and give a definition for it. So sometimes in square root equations or in radical equations, we get an extraneous root. An extraneous root is an answer that appears to be in a solution because you solved for x using all the strategies you've learned, and you got an answer. And you're like, woohoo, this looks good. But when you actually verify it, it does not work. So what does this look like? Well, do we have a square root that's isolated? This is the first time that we've had 2 square roots, okay? And we're going to find out, and we're going to do another example with 2 square roots, when you have two square roots, sometimes you have to isolate one, square both sides to get rid of that one, and then you have to take an extra step to isolate the other one. Now in this case, we're kind of lucky because can you see that the 2x minus 5 is isolated on the left side? And the square root of x minus 7 is isolated on the right side. So they're technically both isolated. And so when we square both sides, because first of all we want to isolate, which is done, then we square both sides, and we would get just 2x minus 5 equals x minus 7. And now it's switched into a grade 9 question of like terms. Can I put like terms together? Personally, when I'm putting my like terms together, can you see that you can move the 7 to the left side, or you can move the 5 to the right side? Is one better or is one worse? Well, yes and no. It's going to work either way. But in a question like this, one of the things that I like to do is I like to look at, I'm solving for x. Can you see if I move my x's to the right side, I would have x minus 2x giving me a negative. But if I keep my x's on the left side, then I'd have 2x minus x where my x would be positive. Generally, I like to keep the coefficient in front of my x positive. So when I'm combining these like terms, I would strategize to say I'm going to move them to the left-hand side. Then, when I look at my numbers, well, I want my numbers on the other side, so then it makes sense to add 5 and add 5 for those like terms. What do I get? 2x minus x is just x, and negative 7 plus 5 is negative 2. So it appears that negative 2 is the answer. And in radical equations, if we just stop without verifying, we might get an answer that actually doesn't work. So when we go to verify this one, plug our left side, plug our right side. In verification, you always go back to the original equation. So here I have square root of 2 times negative 2 minus 5. And on the right side, negative 2 minus 7. Okay? Now, technically, when I simplify both of these, they're the same. Don't they look the same on both sides when I simplified it? So why is this an extraneous root? Because you're not allowed to square root a negative. Like this is not possible. So when verifying and you find out an answer that is not possible, put an X through your answer. You can label it as an extraneous root, and this question has no solution. Oh, one year on a grade 12 exam, a provincial exam, the very first question on the provincial exam, you did like 3/4 of a page of math work. So you did 3/4 of a page of work on the very first question, and then you did what you were supposed to and check your answer, and the answer didn't work, and you had to write no solution on the first question of a 3-hour exam, and then you were like, oh, great. It doesn't really give you confidence when your solution to the first question is no solution. That doesn't seem like it should be a solution to your first question. Okay, so this one has no solutions whatsoever. Okay, and I'm going to get you to turn to the top of page 44. I'll keep it here. Yeah. Okay. Yeah. So top of page 44, I'm going to add another one with 2 square roots. Square root of x plus 3 equals the square root of x minus 5 plus 2. What's that? Yeah, so you just write this on the top of page 144. Because you got lots of room to do the work going down. And we're actually going to skip example 4 as a result. So on the top of page 144, here we have 2 square roots. And the idea, whenever you have a square root equation, is to isolate a square root to get rid of it. Can you see that the square root on the left side is isolated, but the square root on the right side is not? Okay? And sometimes you won't be able to isolate them both at the same time, like the last question. Like if I move the 2 over to isolate this side, then the other side isn't isolated. So what we do is we isolate one of them, which is already done. Then to get rid of that one, we would have to square both sides. Now, I have been putting brackets around things when I've been squaring both sides. It's really important you put brackets around this one because you're squaring the whole side. And remember, squaring means multiply by itself. So it's going to have big implications for the right-hand side. The left-hand side, okay, I'm going to just, can I just rewrite? Instead of the square button, if I rewrite it, that's the same as squaring, right? Okay. The left-hand side is going to be easy. If I square a square root, that just becomes x plus 3. If I square the right-hand side, I am going to have to multiply these out, which means all 4 of those arrows for distribution. And I'm going to get, well, this square root times that square root works perfectly to get rid of the square root. Can you see that? But I'm going to have plus 2 square roots of x minus 5, and then plus another 2 square roots of x minus 5, and then 2 times 2 plus 4. So we started off with 2 square roots. We squared both sides. We got rid of the square root on the one side. Initially, it looks like we still are left with 2 square roots, unless you notice, what do you notice about those 2? They're like terms, or like radicals. So we could combine them together. In fact, here we go. Let's just, we'll take first x minus 5 plus 4 of these plus 4. And now we're down to 1 square root. So how do we solve a square root equation? We need to get the square root isolated. So can I combine everything else on the other side? Can you notice that you could subtract x and subtract x on both sides? And minus 5 plus 4 would be minus 1. I could add 1 to both sides. Are you okay with that? As 2 steps in one, minus 5 plus 4 is minus 1. So to move the minus 1 over, I'm going to add 1 to both sides. So what do I get in the end here? I get 4 equals 4 root x minus 5. Kind of nice that my x's all went away. Yes. So could we square both sides now? Yes. Okay. And you have a choice though. So sometimes I would say square both sides now. If you squared the right side, you'd have to be careful because you're multiplying by itself. Can you see if you squared this side, you'd get 16 times x minus 5. You could also, if you wanted to get the 4 out of here, what's the opposite of multiplying? Dividing. So sometimes dividing makes sense to do it early. I think in this one it would, because the other side divides nicely by 4. Can you see if I divide both sides by 4, then I really get the square root by itself, and my numbers will be smaller. If I squared right away, I would get a 16, which isn't crazy, but squaring now, again, I'll put brackets around it. I'm going to square this side, square this side. You know what the number one mistake is for 1 squared? You know what people write? People write 2. But 1 times 1 is 1. Okay? And this side is now just x minus 5. Can you solve? Yes. Can add 5 to both sides. And we get x equals 6. Nice. Now, did we just do a lot of work in this one? Are we going to be mad if we check this and there's like no solution? Like, probably. Let's check. Left side, hopefully it works. Right side. Okay, what was the original equation on the left side? It was, I have to turn back in my notes because I don't want to flip, square root of x plus 3. So this side will be square root of 6 plus 3. Replace the x with a 6. On the right-hand side, it was square root of x minus 5 plus 2. So on this side, we've got the square root of 9, which is equal to 3. And on this side, we have the square root of 1 plus 2. Square root of 1 is 1. Oh, happiness. It actually works. And it is the solution. Fun times. I'm going to add one. Oh, do I? No, I have to wait. I have another example, but we have to learn another unit before we can do the other example. So maybe it will come out and come back when we've done that other unit. So questions for practice on this one, our number is number 10. And with that, we are going to skip example 4